Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing the Geeks for Geeks Weekly Coding Contest 82, and this was the post contest analysis. So, can I have a quick overview of the contest today? Like, how many problems were you able to solve out of three? Okay, second question was tricky. Yeah, indeed, it was tricky. But a small constraint mention over the last one made it a little bit simple, to be honest. Second question was tricky. Okay. Third question was the famous one. Like it was the like indeed the famous one. Like I have solved it earlier also. Third problem. Okay, zero. Okay, second problem had incorrect test cases. I don't think so. Second problem does not have incorrect test cases. Can you quickly tell me which one? Subarray of 3, 3, 4, 2, 5. Which one? Size is equals to 9. Which one are you talking about? Good evening. Okay. Hi, good evening, Ma. Hi, everyone has solved the second problem. Okay. No queue, first two, no queue to the third problem. Okay. Using hash map. Okay. So now we would start off. I think we are good to go. A lot of participants up here. Okay, I will just simply share my screen, entire screen, and it is. So I would give you a time frame of just 1 minute to just quickly recapitulate the problem. Just quickly recapitulate the problem in 1 minute, and then I would move forward. Just quickly do it. No, we would be following the order that was given in the contest itself. Just quickly recapitulate. Quickly. Okay? Done? Chal. Let's move forward and let's start. Yes. So let's start with the very first problem. Okay. So in this problem, we were asked about. So see, first let us understand what is Fibonacci series. Okay. So first we are in this problem we are explained that what is all about Fibonacci series. So what is Fibonacci series? Basically, Fibonacci series is nothing but a series where the first two numbers are defined. Like suppose this is A and this is B. So the next number would be nothing but the sum of first two numbers, that is A and B, and the next number would be nothing but the sum of the previous two numbers. So B, and then we add to what? We add A added to B itself. So basically this is nothing. The first A and B are defined, and the next numbers we look at the previous two numbers, add it, and this would be the current number. Then we again look previously to the add, and we do this. So this was first explained that what is Fibonacci number. But this is not the question. The question is that you are given an array, okay, and it is told that instead of Fibonacci, what is Fibonacci? Fibonacci is nothing but the sum of last two. This is what is there. But we are told now that we need to have something known as, what is this? Is the name written by something else? Geeky numbers, yes. So we have a new series known as geeky numbers. Okay, so geeky numbers is nothing but sum of last k values. Okay, this is it. So we need the sum of last k values. Okay. So now to explain this problem, how we can think of it, let me first explain you the test cases and I would show you a simple one, how to solve this. Okay. So first let me say, okay, this, and we have to find the nth term. Okay. So see, this is this. So now we can say that the next number would be nothing but previous three numbers. So 0, 1 and 2 is equal to 0 plus 1, 1, 1 plus 2 is equals to 3. So 3. And then the next value, which is 3 plus 2, 5, 5 plus 1, 6. Okay. So we can see that these three numbers made up this value and these three values made up this value. Okay, fair enough. Now we need to think of something. Now if you just see, I would just tell you one thing. Okay, so let's make an array. Let's make an array. Like suppose the array contains n elements. So I would just make it very easy by visualizing. Okay, just see how it gets easy. Okay, let's have the indices too. The indices are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 itself. Suppose here the value of k is equal to 3. Okay. So now see what is happening. Okay. Like suppose we would have a big box here. Okay. So suppose we have the sum of these three boxes as the value. We have the sum of these three, a of 0, a of 1, and a of 2 as the value x. We have this. So can you tell me what would be the next value? If we just observe from here only, you can see that you don't need to calculate the value for this again. Like I would show you the difference between it. Okay, so just see it. Okay, so the next window would be what? The next window would be kind of like this. Not kind of, it would be like this. It would be like this. Next window would be like this. Okay, what would be the next window? So what is the difference between the next window? The difference between the next window was that this value was thrown out and this value was added. So if you just see, this value was subtracted in the next window. This side value got subtracted and a new value got added. And we again move forward. So initially it was 0, 1, 2. Now it is 1, 2, 3. Let me just show you again what happened. Okay, what I'm trying to show you, let me show you again. Just let me go back. Okay, now let us see again. Now I will just show you again. Now suppose k value is equals to 3. So what would it look like? It would look like this. Okay, and 1, 2, 3, 4, 5. So like this, like this, like this. So initially it would contain the sum of all these elements x. Suppose the sum of 2 3 5 2 3 4 5 6 is x itself. So first let me go back and see. Okay, I'm clear enough. Okay, so now see what would be the next value. Suppose this value is x. So the next window would be like this. Like let me show you this. So the next window would be like this. See, the next window would be like this. So I can say that the next window value is nothing but x subtract a of 2 and add a of 7. This is the next window. Suppose this is the window, so the next window would be this. So this is nothing but this value and subtract by this value. Am I clear with this or not? So what I can do is I can use a sliding window kind of approach. Okay. So now I simply have the first k values. I would move forward and I would just remove the first initial value. I would add this value. I would move forward. I would remove this value and I would add this value. So I can simply compute the array itself. Let me see the constraints to have a better understanding. So see, the constraints are just 100. Okay. So sorry, the constraint are just 30. So as array of size 30, okay, the value of 30, the array of size 30, I can simply have it. But there exists a easy solution too. Like you can simply use a loop at each point and you can go back, and this would also work because the time complexity is just 30. But this is the most optimal solution. Okay, so give me a quick one if this is clear. Give me a quick one if this is clear, then I would move forward to the implementation. Give me a quick one. This is not it. This is not hard. Why? Because if you see the sliding window thing, then it might be the scenario that you can say that yes, this is an intermediate level of question. Okay. But if you just use a simple for loop, this would also solve the purpose. Okay. What about others? Can we use DQ in C++? Yes, absolutely. You can use DQ in C++. Absolutely. Absolutely. UQ would solve the purpose very easily, to be honest. But as we are only adding numbers from the back, so I think vector is solving the purpose. Okay. Yes, DQ is fine enough. But see, we aren't adding in, like, say, if we can just leave the number still 30. So if it was said the array size should be 30, then it is okay, then the array size should be equal to k, then DQ is fine. Like we need to remove elements from the first. But see, the array big enough won't matter to us. Okay, like if the even if the array size is 30, why it would be matter? Okay, but if this was given in an interview and if the interviewer had asked you that how can we optimize the space complexity, then you can say I can simply use a DQ and I can remove the elements also, so that the space complexity would remain big O of k at each point of time. Okay, chalo. I think I would need to add the screen and I need to start coding this. And this value would be k. I'm a lazy person, so won't be using shift again and again. And this would be, I would have this as a itself. Very lazy person. You can do this too if you are in a contest to save your implementation time itself. Okay, because we don't really consider the sensible numbers. Okay, so I would have vector of long, and if you're in the contest, I would suggest you that you can use macros also. Like you can just say using ll is equals to long, and you can just write ll at each time. Okay, I would just write vec because I would be using vector, and then I would be iterating on the number itself. So I would be simply using a for loop of int I is less than n. This is simply like iterating over the whole one. And what I would do is sum add to a of I, this one, and then we would insert that value in the new vector itself. Okay, like vec dot push back the current value. What is the current value? A of I. I would just make a new vector. Why to modify that same vector? We can modify it, but I'm doing it. Okay, and see at this point we would say that the beginning point is 0. Like first we would calculate the sum of the first k values. This is what calculating the sum of the first k values. Okay, and then in the next iteration we need to remove the first element. First element's index is what? 0. So first we will calculate the first k value. This is what? Calculating the sum of first k values. Okay. So this would be k itself. or a dot size. Simply solve the purpose. Okay, so now what we would do is we would say while we don't have elements less than n, like till we have not found the element number of elements as n, like the nth element is not found, we would simply keep doing it. So now what we would do is vector dot push back the current sum of previous k element. Now remove the first element, so sum minus is equals to vec of beginning. Remove the first element, add the new element, vec dot back. Like we can have a pointer separately, but vec dot back gives us the last element and we can do it. And then next time we need to remove the second element, so we need to increment this value also, and then simply we would return the value of vec of n minus 1, and this should solve the purpose. Let me just see how many errors are we having. Fortunately, we are not having any errors. Let me try to submit it. Fair enough. I was able to do it. So, do you have any issues? I would just quickly unshare the screen and I would present the Chrome tab. Quickly let me know. I would give you 2 minutes or 1 minute. Tell me the line number or at which point you were not able to understand. Give me a quick one in the chat. Can you explain the input test case 1? Sure. While k is equals to 1. This means the last element. Okay. This is the last element. So see, first was 4. So this last element, so last one element back. One element is 4. Again it would come here. One element back. One element back. One element back. One element back. So it is just like copying the previous element. That is why. Sir, can you please solve it in Java? It would be the same. I think so. It would be very same. Like the same would be the, instead of vector, you can just have array list and you can simply have a pointer to the last element if you don't have the back thing in array list. Simple. Nothing extra. You only need to remember the add and get method. Array list methods are not easy to remember. Who remembers? So to be honest, I uh, used to search or Google search the methods of vector even after 6 months of programming. And the very next thing is, can we change the vector to simple array? Yes, you can simply take an array of you can simply take an array of 100. That would solve the purpose. This task will be solved recursively. What do you think? Whenever you are solving problems in the online judge, try to avoid recursion as much as possible. To be honest, try to avoid. Try to do it iteratively. That is my personal suggestion to you. The last number would be a dot get. Yes, absolutely. Can you do it without extra space? Without extra space? Yes, I can edit the first array A itself. I can edit, or else what I can do is I can simply have a DQ at the moment. I can simply have a DQ here, remove the first element, add the last element. It would solve the purpose. Okay. Just copy the same inputs in a DQ and it would solve the purpose. Let us move to the very next problem. We don't see any problem. Optimal moves. Quickly read the problem. Just quickly recapitulate the problem. This problem is very interesting. So here we just need to flip the bets. Quickly read it. So at 50, okay, 53 sharp, I would just subarrays problem, solve a lot of subarrays problems. Subarrays problems are very interesting as well as very important, to be honest. And subarray problems are, to be honest, tricky. This is problem 3. You're sure? Okay. Just give me 1 sec. I would just do it. Let me just see it. Okay, sorry. Okay, let's do the third problem itself because we have invested our time in what learning about this problem. We would do the third problem at the end. Sorry for that. Sorry, absolutely sorry. I actually forgot it. Okay, please understand. I don't want to do this. I want to follow the order, but by mistake it happened, and I can see that we have invested some time in reading the problem, or you have invested your time in reading the problem. So we would do the good subarrays problem at the end. I don't think it would be an issue for everyone. Sorry, absolutely sorry from my side. Please consider it. Okay, so optimal move. This problem is very good, to be honest. Okay, let us read and understand the problem. So the problem is that you are given a binary matrix. What do you mean by binary matrix? Whenever you hear the number known as binary, it is 0 and 1. सिंपल, कभी भी कुछ भी बाइनरी, बाइनरी बाई मतलब दो, दो मतलब 0 1. कंप्यूटर के लैंग्वेज में दो मतलब 0 and 1. Whenever you talk about binary, binary means two. Computer in the language of computer, we can just have two characters, that is 0 and 1. Simple enough. Just remember this. Okay. So now we have a matrix. Okay. So let me define the matrix in white. Okay. Black and white combination. Now let us see this. Chalo. Okay. Now see, the problem is that this matrix would contain of zeros and ones. Suppose this is 0, this is 0, and this is 1, this is 1, and this is 1, this is 0, and this is 1 again. Suppose this is the value. So now it is said that we can select any row or we can select any column, and we can select it any number of times, any number of times. Okay, like x number of times or infinite number of times. So I would just write infinite times. I can simply choose any row and column, and then I can flip the bits of that particular one. So let's suppose that we have selected this particular column itself. So what would happen? It would happen like this would become 0. Okay, this would become 0, this would become 0, and this would become 1. Okay, now suppose I would select this one. Okay, I would remove this to avoid confusion. So if we select this one, every 0 would be converted to 1. So now let us do this, let us do this, let us do this, and then this would be converted to 1 1 1. Let us do this also. Okay, so by doing this we can do this. The task is to do this operation multiple number of times. How many times you do it, it's not a concern. Okay, and when a number of times you do it, at the end you need to return the maximum number of 1 you can achieve. This is what is next. Maximum number of 1 you can achieve. Yes, maximum number of 1 I can achieve. Okay, fair enough. This is what it's asking. So how can we solve it? Okay. So the very first thing you should do is what you know. You should try to draw this in a pen and paper and you should try to think it greedily. Like, is there a way I can have the maximum one or not? So to be honest, I also did that. Okay. So see, I can say that if I flip the bits of these two, this would be 1, 1, 1. This is fine. But suppose this value is 0. Okay. Or this value is again 0. So if I would again flip the bits, this would again become 0. If I flip the bits of this would again become 1, but this would become 0. So I tried many ways. Okay, like is illustrating the ways I tried to find. Thought process of it, elaborating it won't be of much help because this won't drive you to a solution. I tried many possible ways, but I was not able to crack the solution through a greedy way. Okay. So then I thought I would tell you my thought process. Post contest analysis is not just about solution, it is just about the thought process that you know that yes, I should inculcate this thought process of Siddharth, or I should think like what Siddharth was thinking. So I would try to tell you my thought process, what I tried to do. Okay, so I thought that I'm not able to find a solution to this. So if I'm not able to find a solution to this, what I do, you know, I go back to the question, I read it again. I read it again and I thought, yes, I have read the problem again and I'm not able to solve this. Then I thought that this problem is a little bit tricky. Let me go down to the constraints. When I went to the constraint, when I went to the constraint, I saw an interesting thing. The interesting thing was that N and M is 50 and 14. Okay. Even if this was not given, to be honest, this won't be given in any other online coding contest. And mentioning this was kind of revealing 80% of the solution. Suppose if this is not given. So I would give you a formula. Okay. The mantra of this is that whenever in an online coding assessment test or in an online contest, whenever you see that the constraints are less than 20, then the solution is recursion, then the solution is backtracking, then the solution is about bit masking, or to be specific, power set. Okay, these are the three domains you should try hunting. Why you know? 2 to the power 20, because as you know, the time complexity of all three are exponential. Okay, 2 to the power 20, 1, 2, 3, 4, 5, 6 is less than 10 to the power 8. 2 to the power 21 is more than this. Okay, so remember that 2 to the power 20 less than constraint less than 2 to the power 20 is out of these three. Remember this. Okay, I learned this from at coder contest. Okay, like I saw many problems like at coder problems, at coder contest problems, the ABC ones. What I learned, I would tell you that also. Okay, like सिद्धार्थ को कैसे ये सब पता कौन सा कोर्स फॉलो करता था. This is not about course, this is just about experience. I used to give a lot of contest over at coder too. At coder ABC contest, if you know, I don't know if how many of you know, they also have backtracking problems, recursion problems, and bit masking problems too. A lot. Recursion problems are comparatively very less in other coding platforms, but in AtCoder, CP specific platforms, but in AtCoder, it is quite easy to find. Okay, so I found this. I found this pattern. So remember, this all patterns. Okay, pattern काम में आएगा. You should like the video and comment on the video. कुछ तो फायदा हो रहा है ना. Post contest analysis में time तो बर्बाद नहीं हो रहा. You're not wasting your time here. You're learning something here. So I think you should serve back to us. Okay, the community. Okay, the community needs to know all this. So we can do this. Okay, can you explain the question again? अरे महाभारत खत्म हो गया, ये पूछ रहा है सीता कौन है. I explained the question 3 times. Quickly read the problem and then you can simply tell me what errors are you facing. Okay. So now I found out that this is all about something like this. So I thought that how can I solve this problem? So I thought that I would try every possible ways. Okay. I would try every possible way on the what? On the given column. Why? Because it is less than 14. So I thought of that try every possible way on rows. Okay, I would try every possible ways on rows. Now, the question is how would I try this? Now, to try this, I would tell you a simple thing. Learn this. This is a concept. There is a concept of power set. So whenever, so you can do this recursively also. You can use recursion to solve this. Try all possible ways. You can simply use recursion. But as I told, recursion using stack space. Stack space sometimes give you memory limit exceeded error. So we won't be moving forward with recursion. We would be moving forward with the iterative way. Learn this and it would be useful for the rest of your life. Okay. So whenever we talk about recursion, there is a concept known as power set. Okay. Power set. Suppose I want to know how many, suppose there are three students. Suppose my name is Siddharth. Okay, my name is Siddharth. My friend's name is Manish. And my second friend name is Deepak. Okay, I want to know how many ways someone can select each one of us or a combination. How many combinations do exist? Okay, and what are the combinations? The combinations are that I can select only Deepak. Okay, I can select none of you. I can select none of you. So this just represents. So I would just draw this. Okay. This is Siddharth. This is Manish. This is Deepak. Zero means I would take. Okay, just remember this. Zero means not take. One means take. Okay. So now, what I would do is I would say that initially the first combination would be the first combination would be I won't take any one of them. The next combination would be I would take Deepak. The next combination would be I would take Manish. The next combination would be I would take these two. The next combination would be I would take all this. The next combination would be I would take Siddharth and Deepak. The next combination would be like this. Okay. The next combination would be taking each one of them. So these are the possible combination. Any other combination of selecting between us is remaining or not? Give me a quick 1 or 0 in the chat. I just want to know. Give me a quick 1 or 0 in the chat. Give me a quick 1 or 0 in the chat. Give me a quick one. Any other combination exists or not? A lot of viewers are there. So I expect some people. Okay, this exists. Thanks a lot, Omri EFI. Okay. So if you just observe, to get the combination or to get the way of selecting to either of us is nothing but a traversal from this is nothing but the binary representation of 0, binary representation of 1, 2, 3, 4, 5, 6, 7. So way of selecting, this is just a fact, way of selecting three folks is nothing but the binary representation from 0 till 10 to the power 3, less than 10 to the power 3, and you can do it. The binary representation of all this would tell you this. Okay, this is the fact. So what I would do is I would simply go from 0. So what I would do in return is I would simply go from 0 till less than value of 2 to the power m. If the value is 1, I would flip the bit. If the value is 0, I won't flip the bit. This is fine. Okay. And I would see among all this combination which has the maximum value. Okay. How my thought process is going towards this side? Are you able to get me or not? Tell me. Is the thought process, are you able to have some contribution on your brain that yes, I am able to learn something out of this? So I would try to all these combinations. Okay. Now you would tell me what about rows, Siddharth? You talked about columns. What about the rows? What about the rows, Siddharth? Can you tell me? So see, rows is very easy to say. Okay, if we are using every combination, so see, this is using a combination. Like this would try every possible way. So row mein what I can do is I can use a greedy approach in row. Okay, so I would say that if the number of 1 is more, if the number of 1 is more, I would flip the bits. If the number of zeros is more, I would simply keep quiet. Or I can say if the number of 1 is less than 0, 1 is less, I would as it is. I would simply leave it as it is. Solve the purpose. Okay. Am I clear with this or not? Then I would move forward to the implementation. Give me a quick one if you are able to understand this. Give me a quick one. Why not trying? Yes, absolutely. We would apply power set for columns and greedy for rows. This is what it is. Okay? समझ में आया ना? Like how this is done? Sahil, can you tell me at what point you are not able to understand? Tell me the point at which you are not able to understand. How did we apply this power set method for this rows and columns together? How to relate this with the question? Greedy for both won't work. When to flip, when to not. So see, first the column would be decided by the recursion, or column would be decided in each possible ways. Column would be decided by each possible. Column को देखो, I would explain this in Hindi. Okay. Column को पावर सेट के भरोसे छोड़ दो. पावर सेट क्या करेगा? हर तरीका का यूज करेगा. रोज में क्या कर सकते हैं? रोज में हम लोग ग्रेडी अप्रोच लगा दिए सिंपली. प्रॉब्लम कहाँ आ रहा था? इंटरसेक्शन में. Why do we use greedy for rows as well? Why not power set for both? Because we can't judge. Okay, why can't we use greedy for rows as well? Why not power set for both? So see, power set for both would definitely work, but that would hamper the time complexity. The very first thing. Power set would work for both. Like we can use power set for both. But what was the problem? Let us see what was the problem. So see, I would explain you this. So the problem was on this side. Okay. So see, the problem was this. See, suppose we have something like this. Okay. Suppose this was 0, 0, and this was 1. This was 0, 0. If we flip the bit of this, okay, if we flip the bit of this side, this would get hampered. If we flip the bits of this side, this would get hampered. So the problem was when there was an intersection between the rows and columns. So if somehow I can remove the column thing, then rows के लिए तो हम लोग ऐसे ही कर सकते हैं कि जो ज्यादा होगा उसी को मैटर करो ना. अगर ज्यादा 1 होगा तो उसे 0 में चेंज कर दो, ज्यादा 0 होगा तो रहने दो. प्रॉब्लम हो कहाँ रहा है? Okay, like whenever you think of greedy, problem हो कहाँ रहा? Problem was occurring when suppose रो का किया तो रो कॉलम बिगड़ गया, कॉलम किया तो रो बिगड़ गया. This was the problem, na? Like when you try to solve this greedily, problem, what was the problem? Whenever you are trying to fix the row, column is getting disrupted. Whenever you are trying to fix up the column, row is getting disrupted. So we need to segregate between row and column. So what we did, we handed the columns to the power set. So एक अगर पावर सेट संभाल लिया तो रो का क्या करना है? रो में ज्यादा जीरो है तो जीरो, ज्यादा जीरो तो रहने, ज्यादा जीरो है तो वन पे चेंज कर दो, ज्यादा वन है तो उसको जीरो पे चेंज कर दो. सेम थिंग. जो ग्रीडी होगा, जो फायदेमंद होगा. एम आई क्लियर नाउ और नॉट? गिव मी अ क्विक वन और नो. टेल मी, एम आई क्लियर विद दिस और नॉट? इतना मेहनत किया. Whenever you try to solve it greedily ना, this would be the problem कि ये intersection ही main problem है. Okay? अब तो लाइक करना चाहिए ना? अच्छा लगा ना? कमेंट भी कर देना. अच्छा लगेगा मुझे रात में पढ़ के. चलो, let's move back to the coding part. Okay, chalo. I would simply have this grid as A itself. Okay, simple enough. I would initialize the answer is equals to 0 because initially we are not able to make any progress. Now I would move to for int I is equals to 0, I is less than 1 dash dash m, and then I plus plus. So what is 1 dash dash m? I would try to explain you this also. 1 dash dash m is nothing but 2 to the power m. Okay, how it is? I would tell you that also. So see, 2 to the power 2, I would simply have 1 0 0. This is nothing but 2 to the power 2. That is 4. 2 to the power 3 is 1 triple 0. This is 8. That is how it is. Just remember this. These are some bit masking tricks that you need to understand. Or else pow 2 to the power m. Pow 2 to the power m would also work. I can simply say pow 2 to the power 2 comma m, and this would also solve the purpose. Remember this. I am trying to explain you bit by bit. इस छोटे छोटे चीजों में ही आपको समझ आती है. इस छोटे छोटे चीजों से ही आपकी नॉलेज बढ़ती है. कोई कोर्स नहीं. After a certain point of time, you don't need a course. After a certain point of time, you only need a good problem solving mentor, some good problems, and a good friend who would sit with you for discipline. बस इतना ही है और कोई नहीं है. To be a good coder, you don't need a super useful course or something. After the basics, the value of course gets lowered down, the value of problem solving gets increased. जितना प्रॉब्लम बनाओगे उतना सीखोगे. सिंपल सा है. ओके, चलो. vector of int of current. Why this? Because we are flipping the bits. So if we flip the bits of the original array, then we can't flip it for the next one. So we would copy that array. We would copy this array. Now we would start flipping the bits. For int I is equal j is equals to 0, j is less than m, and then j plus plus. Now I would say that if the value of 1 less than equal to j, okay, and I, this is what? This is checking if the ith bit is set or not. If the ith bit is set or not. This is just checking this. Okay. Okay, I need to have this lower down. Yes. Okay. यहाँ तक आ गए. This is just by checking. Now there is one more thing to flip the bits. So see, अगर मुझे bits flip करने हैं, so there is a smart move. I would tell you this is also for some other values also, like I would tell you that. So see, suppose I want to flip the bits. So 0 अगर रहे तो मुझे 1 करना है, 1 अगर रहे तो 0 करना है. So what I can do is I can simply subtract it by 1. So if 1 minus 0, suppose this is the value, then it would be converted to 1. If this value is equal to 1, 1 minus 1 is equal would be equal to 0 itself. So just have you seen that अगर 1 से माइनस करो वो वैल्यू तो वो 1 रहे या 0 रहे वो फ्लिप हो जा रहा है. 1 माइनस 0 किए तो वो 1 में कन्वर्ट हो गया, 1 माइनस 1 किए तो वो 0 में कन्वर्ट हो गया. So to flip the bits we can simply say that yes, if I is equals to 0 make it 1, if I is equals to 1 make it 0. I can use two if statement. But instead of that, I can simply subtract it by 1. And my coding, how will that be effective? It would impress your interviewer. It would save your time. The implementation speed would be much more. You need to write less. That is why. Okay, so remember, you would work a lot with binary. So learn all these tricks. Okay, there are some more tricks to bit flipping for more also. Like for 1 and 2, what you can do is 3 minus 1, it would be 2. 3 minus 2, it would be 1. So 1 रहेगा तो 2 में convert हो जाएगा, 2 रहेगा तो 1 में convert हो जाएगा. So subtracted by 3. Okay. Remember these are small tricks. This won't be given in any course. This would be done by problem solving only. कोई कोर्स इसमें काम नहीं आता. कौन तुम्हें इतनी छोटी बातें बताओगे बताओ. एक अच्छा मेंटर हो वही छोटी छोटी बातें बताएंगे. Okay, for k is less than n and k plus plus. Now what we need to do is we would simply do, okay, cur of k and j. Okay, cur of k and j will be equal to flip karna bits na. So 1 minus cur of k and j. That would simply flip the bits. This is what flipping the bits in a smart way. यहाँ पे थोड़ा और लिखना पड़ता. If k of j is equals to 0, make it 1. If k of j is equals to 1, make it 0. We need to write more. We are writing less. Okay. So this is done from this side. Okay. Now we would have the temporary answer. So int t answer is equals to 0. Okay. This would store the for each values. Okay. So now we would say for int j is equals to 0, j is less than n and j plus plus. Okay. And then I would simply have the count of it. And then simply cnt is equals to 0. Okay. Now I would iterate over the rows. Okay. I would iterate over the rows because columns handle हो चुके हैं. अब rows को handle करना है. Okay. So rows को कैसे handle करेंगे? Just see it. For k is equals to 0. For int k is equals to 0. Okay. K is less than m and then k plus plus. And then you would simply say current plus equals to current of j of k. Because see, 0 won't contribute to the answer, 1 would contribute to the answer. So if it is just like this, suppose this is what? Suppose this is 0, 0, 1. So it was the addition of all these values is 1. If suppose this is 1, 1, so addition of these values will be 2. So we can simply add all the values of a binary digit and it would tell us the number of ones we have. Okay, simple enough. Now what we would do is we would use this side. See, T of answer में क्या add होगा? What would be added in T of answer? So see, T of ans plus a is equals to max of जो भी हो. अगर 1 ज्यादा है तो रहने दो, अगर 1 कम है तो उस पर बिट्स फ्लिप कर देना है. ओके, तो बिट्स फ्लिप करना मतलब क्या? 0 और 1 ही है ना, तो 1 0 में कन्वर्ट हो जाएगा, जो ज्यादा है उसको ऐड कर दो. ओके, एंड देन वी वुड सिंपली return the result of this, simply return the answer of this. Okay, now after t of answer, we would go here and we would say answer is equals to max of answer comma t of answer. Okay, so this is for iterating over all the values. So first we are having this, then we are iterating this, and this would solve the purpose. Now let us see this, if we are getting a correct output or not. We are not getting a correct output. So vector of indent curve is equal to A. So what is it asking? You have to move CVP 1328, 30 and 28. Okay, count is equals to, this would be count plus equals to J of K. Now let me just see again. Okay, we are getting correct output. Now let me see. Chalo. We have got the correct output. Now tell me at what point you were not able to understand. Yes, screen. Why is the screen flickering a lot? Optimal moves. Chalo. Tell me. Okay. Sir, question name दिखा देना. This question name is optimal moves. This is the question name. So, chalo. Sir, can you please keep speaking English? Yes, absolutely. I would. I tried to move forward with English, but I would tell you my condition. What happened was, I am from a small district in Jharkhand. Okay, I belong from Jharkhand, so in Dhanbad. Okay, so it is not small. Okay, but it is okay. So we have a majority of people who are not comfortable with English. Okay, so I respect that a lot. So that is why sometimes I repeat my same idea in Hindi so that people would connect with me better, and sometimes same चीजों के हिंदी में करने से people understand a lot better. Okay, sir, when will you graduate? I'm a 2023 batch pass out. Currently I'm in my final year doing my internship, so I would graduate in the next year. This is true, but this is true. I would simply, this is true. So, why greedy for both won't work? Because we are not able to find a way to solve it. So, see, if we are not able to find a way to solve it, like whenever we are trying to, so whenever there is an intersection of rows and columns, if we try to fix the rows, the column would disrupt rows column. We are not able to find a way. Agar we are not able to find a way, then that value is not greedy. When greedy fails, recursion or dynamic programming comes into picture. Okay. Sir, matrix. So no, we don't need to return the matrix in the same state. Why? Because we just need to return the maximum number of values we can have. Okay. Can you please explain the loop for greedy? Can you quickly explain? I'm getting floating point exposure. Oh, bhai, बहुत बढ़िया. Okay, thanks a lot. So I'm getting floating point exception. Please see to it. Sometimes you are, I think you are not using long or something. Okay. Can you explain the for loop for greedy? Yes, absolutely. Why not? That is my job only. So see, what we did was, see, suppose we had 0, 0. Okay, I'm not. You are not able to see. I understand. Stop sharing, and then I would share the screen itself. Never mind, fixed it. Chalo. I then I owe you a party. You owe me a party. Remember to give it to me. Chocolate to banta. I deserve a chocolate at least. So see, what would happen is this is just like this. Suppose this is 0, 0, 1, and suppose this is 1, 0, 0. So see, what we are doing is we are adding the values. So we are adding the values of this. So this would give me a 1. This would give me 2. So we are getting the total number of 1 in the total matrix by doing this. And then you would say, what is all this about? So see, this is all about that. Suppose a given matrix, suppose the given matrix has greater number of zeros. If the greater number of zeros is there, then we would just flip it and we would make it to 1, 1, 1, 1, 0. So this is just like this, that suppose the given number of zeros is 3, The given number of 0 is 3, the given number of 1 is 1, and the total length is equal to 4. Then I can say that either I would use these zeros. So this is just like this. Either use one. Okay, either use just only one that is already there, or either use what? Either use this value. Okay, the number of zeros. Either use the number of zeros or either use the number of ones. Okay, so this is just like this. मतलब जो फायदा है उसी पे जाओ, सिंपल. अगर जीरो ज्यादा है तो जीरो को वन में कर दो, अगर वन ज्यादा है तो वन को, अगर वन ज्यादा है तो रहने दो, जीरो ज्यादा है तो वन में कन्वर्ट कर दो. इट इज जस्ट लाइक सेम थिंग, द greedy approach. I am very greedy. I want more one. So if the number of zero is more, I would convert it to one. If the number of zeros is more, if the number of one is more, then I would leave it, because that is my end goal, na? Okay, chalo. Chalo, I think the last question. Please try to read the question a little, try to read and understand the question a little bit fast, because I need to have my dinner outside, because of this contest I didn't have my dinner. So I would quickly go out and have the dinner. So please so don't drag it a little bit. Try to complete it soon so that the shops would be open and I don't need to sleep empty stomach. Okay, you are getting comments after some time. I comment before you wrote the code and comment when you solve the question. Yes, there is a delay. Okay, there is a delay between, like, you would comment it and then I would receive it after some time. Quickly read the problem. Quickly read the problem and then I would explain you. You explain very good. Thanks a lot. Can we move forward? Give me a quick one that yes, we can move forward. Give me a quick one that this is clear. And if suppose, see, if this thing you are able to like this thing, you learned something from this stream for free, try to give it back to the community, like the community is providing you to this free, so try to give back to the community. So just try to have a small word of appreciation if you liked it, or a small word of improvement if you want me to improve. What I would do is either I would improve or either I would smile at the end of the day seeing your text. Chalo, let us move forward then. Okay. See, this problem is a very famous problem, and if you have not solved this problem earlier, then I can say that solving this problem in the first hand is very tough. Okay. This problem is a little bit tricky to understand. Like when I first solved this problem, this was indeed tricky. So I would quickly explain you the problem. The problem says that first let us understand what is subarray. Subarray is nothing but a part of the array, a continuous part of the array. This is what is subarray. Okay, non-continuous won't be a subarray. It is asking us that how many subarrays are there which satisfy some condition. What are the condition? That there should be exact there should be exact x element that have occurrence more than 3. This is what it is asking. First, it should be a subarray, and the next thing is there should be exactly x element such that each one of them occurrence is more than 3. This is what it is asking. So if you see this problem seems a little bit tricky in the first go. Like exact x element. How would I do it? This is very hard. Like exact x element, first window would be this, the next window, how would I be able to know कि exact कैसे आएगा? I too thought about this problem, and when I was solving this problem back initially in my initial days, I thought a lot about this problem. But there is a trick to this problem. The trick is, try to understand the trick itself. This is a tricky problem. Like, this is not intuitive, to be honest. Okay, like, you need to remember this trick. Whenever you are asked about a problem of exact, okay, and you are not able to solve it, so there is a trick. Like, see, suppose it is asking us for exact 5. So I can have exact 1, exact 0, exact 1, exact 2, exact 3. Or suppose whatever. Suppose it is asking for exact 5. Anything. Exact 5. So I can have, the answer can be exact 1, 2, 3, 4, 5, 6, 7, and 8. There can be exact many these ways. Okay. So I can say that at most 4, at most ज़्यादा से ज़्यादा 4. If I remove at most 4, if I remove at most 4, if I remove at most 4 from at most 6, if I remove at most 4 from at most 6, okay, then the remaining one would be at most, then the remaining one would be absolutely exactly 5 or not. Or I can say that at most 5, chalo, this is at most 4. Just remember this, at most 4. And I can simply have one more, at most 5. So at most 5 minus at most 4 is equal to exact 5 or not. Give me the answer to this. At most 5, at most 4. If we remove that, it would be exact 5 or not. If we remove at most 4 from at most 5, then the remaining one would be exact 5 or not. Give me a quick yes or no. And this is the trick to this question. And this is a trick to many other problems, to be honest. Just give me a quick yes or no. Give me a quick one. You will not get the subarray then. Will sorting in an array? No. Whenever we are talking about subarray, try to remove sorting from your head. Sorting won't solve the purpose. Why won't sorting won't solve the purpose? Because in subarray, the elements need to be contiguous from the original array. If the elements need to be contiguous from the original array and sorting would disrupt the ordering, then how will that help? Sorting won't help. Whenever we are talking about subarray, sorting won't help. Okay, I would reply Abib Rahim at the end. I don't get about the first two loops. You don't need to talk about loops. बस इतना बता दो, at most 5 minus at most 4 is equal to exact 5 or not. I'm not talking about formulas. As of now, I'm not talking about any problem. Any problem. I'm just talking about this line or not. How is this famous? Is it a part of some standard problem set? Yes, it is. Indeed, it is a part of some standard problem set. Am I clear with this or not? Am I clear with this line or not? Kothapalli? As of just tell me about this line or not. At most 5 minus at most 4 is equal to exact 5. Am I clear with this or not? At most 5 means what? Jada se zada. At max. At most is at max. At most is equal to at max. So I can say that at max, okay, at max 5, at max 5 minus at max 4 is equal to exact 5 or not. Okay, see. चलो, everyone is clear with this? Then it is clear. चलो, problem solution समझ में आ चुका आप लोग को. Okay, you are done with the solution. Trust me, I would tell you this. So see, this is now a very two-pointer question itself. So I can say that the question is now, the question has nothing but find the number of subarray, find the number of subarrays where at most x element have occurrence of 3. Okay, so I can simply say that I would have a two-pointer kind of thing, and this is a two-pointer famous question. Just this is a sub part of this problem, so I won't explain this sub part of it. So just if you are not able to understand this part, after this part, just go out and learn about this problem. Okay, this is an application of two-pointer. Okay, so find the number of subarrays where at most x values can be there. So I can simply say that I would simply count the number of values. Okay, I would just explain you this also. So there would be a pointer of right and there would be a pointer of left and right. Okay, so there would be a pointer of left and there would be a pointer of right. Okay, so I can say if any value, if more than x value, more than x value exist, then I would increase the left pointer. Why? Because I would lower down the gap. Because at most I can have x. So if more than x is there, so I would reduce this. If I have, else I would simply try to drag the right pointer. Okay, and right minus left plus 1 would give me the value. Why? Because see, suppose we have 1 0 1 2 3 4 5. Okay, and the right pointer is, left pointer is this and the right pointer is this. So what is the length between them? Length between them is right minus left plus 1, which is equal to 4 minus 1 plus 1 is equals to 4. So see, the value is 4. This is the formula to get the distance between two pointers. Okay, this is the formula, right minus left plus 1. Okay, now the question is that see, each values would have at least one value. Okay, at most. So we can simply do it. Right minus left plus 1. So at most x minus 1 would solve you the purpose. If you're not able to understand the last part of it, go out and learn about this problem. And if you want, I have already explained this problem. Okay, you can search my video also. If you are comfortable with the learning, if you are comfortable with the teaching of mine, you can search this problem also. This is a sub part of it. Okay, I've explained you, and this would be more clear when we implement it. So I would move to the implementation now. Can I move to the implementation a bit? Tell me. थोड़ा सा जल्दी करना so that I get to have my dinner. It's 9:40 now. So shops would be closed by now. Okay. So no issues. I don't have. I can skip the dinner. That's fine. But still, if you can move forward a little bit. Okay, it is clear. Okay. For anyone which is not clear, so it would be clear after the implementation. Even after that, if it is not clear, I would explain you again. No issues. Okay. I'm a leasing person, as I told, so I would simply have a here itself. Okay. So I would have here long again, and this would be at most. Okay, at most k values. Okay, and I would simply copy all these values from here itself. Int n, int x, at most x. So this would be simply but at most x. Okay, so n x, and then the vector that is already there, vector of int, and I would just pass by reference. Okay, I would just simply pass by reference, and then I would take a map of int and int to remember the occurrence. Remember the occurrence, I would simply take a map. Now I would have the count is equals to 0, and then I would have a left pointer which would point to 0 and the right pointer which would point to 0 again. Okay, simply. And then I would have long res to store the result. Okay, एक left pointer लिया, right pointer लिया, एक count लिया to count the values, count the number of values greater than x, एक rest लिया to store the answer. Simple. Now I would say while the right pointer, this is the right, while these two segments, left and right, is within the boundary. How it is within the boundary? The right should be within the boundary. Left तो this side ही रहेगा ना, left तो right के left में ही रहेगा ना. So this side, this should be within the boundary. If this is within the boundary, this is also within the boundary. So I can simply say you can have left is less than n, but right is less than n would solve the purpose. Okay. Now I would say that if after adding MP of A of right, okay, plus that after adding this right, we would simply move forward. After adding this, if the number of occurrence is equal to 3, if the number of occurrence is equal to 3, okay, is equal to 3, then I would close the bracket and I would say Cn plus plus. So Cn बढ़ गया. Okay. Now I would say while the number of values like this is more than k, okay, the count is more than x itself, while the count is more than x. So what I would say is that if of a of left plus and after having it negative minus, okay, equal to 3, and count minus cn minus, and then after all this is done, okay, after all this is done, we would get out of the while loop and we would simply add this res plus equals to right minus left, okay, right minus left, and then we would return the res after the while loop, and the value of res. Okay, so this is what we are increasing the count. After that, if the number of values is more than 3, okay, suppose that we at most x, so if the number of values is more than x, then we need to lower it down a bit. So we have lowered it down a bit. So this side left would increase and the number of count would be less. At the end, res plus is equal to right minus left, and we would return it. Now the answer is very simple. Okay, add most x. So I would say return at most of n comma x comma a, subtract by at most of n comma x minus 1 comma a. At most x minus at most x minus 1 would give you exact x. Let us just compile and run and see how many errors are we making. Okay, this is empty. Chalo. I'm clear. I would just have this. I would stop sharing the screen. I would share you the Chrome tab. Good subarrays. Tell me the line number at which you are not able to understand. Sir, I'm asking questions from optimal moves. It came now. I don't know. I think it might be an issue with your UM की जगह MP होगा. Yeah, absolutely. It's done. Okay. So just give me a quick E1 if you are clear. 53 people are watching at the movement. So I can at least expect more than 25 replies towards the end of the video that yes, everyone was following. How to write line number 19 in Java. Okay, so you can just count the number of values. If after incrementation, you can say if after incrementation, if count of MP of A of right is equals to 3, then Cn plus plus and then R right plus plus, it would be the same. Okay, so now I would reply, for counting the numbers of why do we use left minus right? For counting, because see, at most x. So if one, so how why did we count it? This is also an issue. चलो मैं बताता हूँ. See, I don't know why it is flickering. Yes, चलो हो गया. चलो मैं बताता हूँ, ठीक है? So see, suppose the number of values are 1, 2, 3, 4, and 5. So see, at most 1 means I can take 1 also, I can take 2 also, 3 also, 4 also, and 5 also. And I can take the whole array also, 1, 2, 3, 4, and 5. That is why I am simply adding the values at each point. Okay. So for 1, 2, and 3, so I would simply add 1. Then I would add 2, 1 and then 2 and then 3. So if you observe, there are three possible combinations. So 1 plus 2 plus 3, 1 plus 2 plus 3 is equal to 6. How 6? Only 1 can be there, 2 can be there, 3 can be there, then 1 and 2 can be there, then 2 and 3 can be there, and then 1, 2 and 3 can be there. That is why if we just add 1 plus 2 plus 3, we would have these all combination. That is why we add the length in two pointer. In two pointer, we add the length. This is the reason why. 1, 2, 3 can be 1, 2, and then again 3. Then we can consider two elements, then we can consider three elements like this. That is why for the array of size 3, at each point, we are adding the length at each point. So this is just like this. So suppose this is 1, this is 2, and this is 3. So I came here, added 1. I came here, added 2. I came here, added 3. So at each point, I would add this. At the end, I would get the final result, which would tell me the number of subarrays I can have. This is just counting the number of subarrays. Okay. Any more, Rishit? Can I increment before the loop? Yes, absolutely. You can increment before the loop, and that would solve the purpose just fine enough. Okay. Give me a quick one, quick one, quick one. Okay. So I would just quickly cater this doubt. Okay, so I have been getting this doubt a lot. Okay, to be honest, okay, like whenever I have a good stream with a, like whenever I had a stream with Striver, whenever I have a stream with Nishant sir and all, whenever I have a stream with Sandeep sir, I get a lot of doubts regarding this. Okay, so you are very good, you come from a tier 3 college, how did you manage this? How did you manage that? Okay, so see, my path was absolutely very simple. What I did was, for the basic, like to be honest, I followed a lot of wrong path. But I would explain you the most optimal path of mine, which I followed to get to this point. What I did was, till an extent, I followed a resource. After that thing, I left that resource and I started problem solving. And by doing problem solving a lot, I learned a lot of things. Like when I learned about two pointers, I learned about 1 plus 2 plus 3. When I learned about bit masking, I learned about power set. This is how I learned in my days. Okay. Were you involved in any, like where you, how did you manage with your friends and all? What were this? To be honest, I tried to have had a group in the college itself, but no one was bothered enough to have friendship with me regarding this coding thing, because very few people, at a max one or two people, were doing competitive programming in my batch at that point of time. Nowadays, few people, 4 or 5 people, do it, but at that point of time, many people were not doing it. So I quickly learned it. I used to skip my college. I used to stay at home or at my PG or at my flat, and then did coding for the rest of the, like I had a storm, like had a small background music towards the end. Like it would, like I had a small speaker. It would be situated in some corner. I had a small background music and I used to code for the rest of the day. And when I was preparing for this all comparative programming and all, I used to code a lot. I used to solve problems a lot. Sir, can we solve by using this approach in the first question? Yes, you can do it. Simple enough. Any more concerns do we have? If you have any more concerns, you can simply do it. I would be waiting for the next 2 minutes and then I would be turning off the stream. If you have any concern, I would be waiting for the next 1 or 2 minutes and then I would be turning off the session. If you have any doubts, quickly ask me, else I would turn off this session itself. Most welcome. How do I approach tree problems? So to approach tree problems, the best one would be that you visualize the tree. You use some visualizer. My favorite one, my personal favorite one is the CS Academy Graph Visualizer. You can use that. Try to visualize the tree. So you would get an approach like, yes, I need to move in this manner. I need to first hit the left and then right. So I would say yes, left and then right. So it would be in order, post order or pre order. We have this thing. Okay, BST or anything. I really thanks a lot. Thanks a lot. There are few people, like a bunch of people, around 4 or 5 people who do admire me in a big world of Take You Forward, Nishan Chair and many others. There are 2, 3 people or 4, 5 people who still admire me, and I am happy with that. Okay, I think no more issues to cater. So if you found this insightful and if I was able to contribute to your knowledge of coding even a bit, you can give back to the community by commenting on the video and liking the video so that the reach of this video could be increased and my work could be justified. This is Siddharth Hazra signing off. Thank you, everyone.